Hello, welcome to section 2 of the atom. And so this is all covering discoveries after Dalton. So remember, if you can remember, John Dalton gave us the idea of the atom, that it was an indivisible unit, and he even backs that up with some claims. And so now we are going to further extend that idea and learn about a little bit more history of the atom and add just how we learned new things through different experiments. So there are a few scientists. This video is a little bit more heavier on the information. There's a lot more to write. We are going to talk about a lot of stuff and add a few things to your notes. So you may want to leave some space in between each slide. After this, you should be able to distinguish between the three main subatomic particles. You should be able to understand the contributions of J.J. Thompson, Robert Millikan, and Ernest Rutherford to the atomic theory. And you should also be able to describe the structure of the nuclear atom. If you feel like you are not able to do that after this video, that's okay, because we'll do it in class as well. So let's talk about Dalton's downfall. Unfortunately, Dalton was not almighty and right. He used experimental evidence to support his theory, which is great, right? It's better than Democritus, who had nothing to support him. But it had a lot of shortcomings. One of the biggest shortcomings was that he strongly believed the atom was an indivisible unit and that there was nothing else within an atom. It was almost like a hollow ball, if you will. So he has no way of explaining different actions of certain compounds and certain elements and the way they act when they are in certain reactions. So in the 1800s, it was found that the atom could be broken down. And so here, Dalton's theory kind of gets taken and I wouldn't say ran through the mud, but it's just been revised quite extensively. And so now that's where we're going through. So the first revision was done by a guy by the name of J.J. Thompson. So J.J. Thompson comes in and really he makes a huge discovery that contributes to the atomic theory on accident. So that's a pretty happy accident. What he was really doing was trying to study electricity and how it worked with matter and what electricity, the relationship between the two. And so really this was just a happy accident. He happened to come upon electrons. And so what he does is he does an experiment known as the cathode ray tube experiment. And I am going to show you this in class. I will have a picture and you will draw this picture and label it. So do not worry about doing that now. We don't even have enough room for me to draw it. But what I do want you to know is that there was a ray that was passed through a cathode, which is the negative end of, it's almost like a battery, but it's really just a tube. And this ray passes through, it goes from the cathode, which is negative end, to the anode, which is the positive end. And what that ray is just electricity passes from the cathode to the anode, to the power source. What J.J. Thompson noted from this experiment was that the cathode ray tube experiment supported the hypothesis that the cathode ray consisted of a stream of particles that have a mass. So what he figured out, which is kind of astronomical how they figure these things out, but what he figures out is that when that ray is shooting at something, it has some kind of mass, it's doing something, it's not acting in the way he expected. So after further investigations and after further experiments, he shows that the cathode rays are streams of negatively charged particles, and he does this using a simple magnet. He just holds it against the ray tube and then sees which way the light is moved, or I guess the ray is moved towards or away from the magnet. And depending on which way the ray goes will determine the charge of the particles. And in this case, he figured out that these particles were negative. And he ended up calling them the electron based off of the experiment he was doing off electricity. So negatively charged particles known as the electron. He comes up with this model known as the plum pudding model. Super fancy. I will show you a picture of plum pudding. It's also really disgusting if you ever want to try it. Now, some years pass, and bear in mind that my years may be a little bit off. So when you do your timeline, you are going to want to look these dates up a little bit more officially and do a little bit more of a chronological order. I feel like I'm doing all right, but I could very well make a mistake. So it's something you do want to double check. We have Robert Millikan who comes in, and he is our first American up in this whole game, which is pretty cool, right? Robert Millikan, he carried out a few experiments. What he did is he basically, it's called the oil drop experiment. And so he investigated the way oil drops picked up static charges when they were suspended between two charge plates. And this is the way he figured out the mass of the electron. And you probably don't think that's important, but because of this experiment, it helped determine, because the mass of an atom had already been figured out, it helped determine the fact that there was more than just the electron in an atom. There are more things in there. And so this led to the way of figuring out the other subatomic particles that make up an atom. So again, he does the oil drop experiment. He figures out the mass of the electron is 9.11 times 10 to the negative 28 grams. Super darn tiny. This led to the idea that atom must be made of more than just electrons, like I already said. So after Robert Millikan, there comes new players in our beautiful game, and we have what's known as protons and neutrons, and these are not found exactly at the same time, but they are found approximately close to one another. So the proton was discovered by Eugene Goldstein, and he discovered evidence for the existence of a positively charged subatomic particle. And what he does is he manipulates the cathode ray tube experiment. So he is doing the same experiment as Rutherford, but now he's just manipulating this experiment to see which way, if we have negatively charged particles that are being attracted one way, then we have to have positively charged particles. There's always opposite with everything, and so the positively charged, he was wondering where those went. And so he manipulates this experiment, and he ends up finding that positive charges from the array were traveling in a certain direction, and so he ends up capturing those and figuring that out. And he calls these positive charges protons. So these are known as protons. So right now we have electrons and we have protons. Remember, electrons are negative, protons are positive. And here comes a new player. So I'm kind of going through this pretty fast. I realize that. If you are overwhelmed, it's all right. We walk through it pretty slow in class sometimes. James Chadwick, in 1932, discovered a third subatomic particle known as the neutron. And those are the three subatomic particles in the atom. So an atom is made up of protons, neutrons, and electrons. And at this current moment within history, there is really no huge proposal on what the atom looks like. Most people are under the assumption that the electrons, protons, and neutrons were just located anywhere within this round ball, if you will. And so what happens is you have a new guy by the name of Ernest Rutherford. And little fun fact, Ernest Rutherford was kind of a jerk. He wasn't very nice about things, but I mean, I guess in order to win a Nobel Prize, you need to be a jerk, right? So Ernest Rutherford in 1911 sets out to change the model of the atom. So we go from all of these experiments that are done, and it's kind of not been a super proposed model, but then Ernest Rutherford comes in and he is full on willing to take on, and he's not ready to accept the model that's presented, so he takes on his own thing. And what he does is he does what's known as the gold foil experiment. You've probably heard about this all of your science career. He basically discovers the nucleus of an atom by shooting alpha particles into gold foil sheets. So you may be thinking, well, what's an alpha particle? Well, alpha particles are they're just a positively charged particle whose mass is about 4 times that of a hydrogen atom. So it's basically a product of radioactive decay. I don't expect you to know that little fun fact, but what he does is he shoots the alpha particles at a piece of gold foil, and what he expects to see is that there should be slight deflection or none at all. So he's shooting these alpha particles at the gold foil, and again, he's expecting to see slight deflection or none at all. Surprisingly, though, he sees that these alpha particles are indeed undeflected. A very small percentage bounced off the gold foil at very large angles. Some were even redirected back towards the source. So he really was not ready for this. He was like, whoa, what is going on? He even goes as far as talking about relating this to shooting guns. So he ends up deciding, well, I need to come up with an entirely new model to explain his results. So he ends up coming up with this idea of the nucleus. inside of the center of the atom, and it's a tiny, dense central core of the atom, and that has protons and neutrons. So the protons and neutrons are held within the nucleus. The electrons are surrounding that. And you will find out when we start talking about Niels Bohr that some of these things are not explain, like it does not all explain electrons. And if you hear Jace in the background, sorry. If you have any questions, please ask me on Edpuzzle.